All right, I'm going to do a video on shaft encoders, rotary encoders, yeah, these things. And you'll find them in lots of instruments and stuff, your oscilloscopes and front panels of things with rotary knobs. And so there's cheapy ones. These are the real cheapy ones, and they're more mechanical in nature. So they're good for minimum service life. Then there's real fancy ones like these, which are optical in nature, and they last a long time, but of course they're way more expensive than these kind. So you know, my Raggle scope probably uses the cheaper ones, and my 7300 ICOM has this one big knob here. It probably has a fairly expensive encoder on that. And so anyway, here you go. These are pretty representative of cheap ones, and these are quite old now, but these are pretty representative of the expensive ones. All right, so first thing we'll do is we'll take a look at the mechanical ones. Let's hook one up and see how they work. Okay, we're going to hook one of these devices up, and they are going to be three legs, and they're going to go into the encoder. The middle leg we're going to tie to ground, and then these two are going to come out, and we're going to put LEDs this way around. Sorry, LEDs like this. +5 of 1K, a 1K, 1K. So, oh, sorry, I'm not on camera. And so, yeah, so these will be LEDs. And as we turn the wheel, there's basically a switch on this side and a switch on this side. So as we rotate it, it'll close this switch and the LED will light up. And when we rotate it, the switch over here will close. And right now I have it, so this is a blue LED and this is a red LED. So we can see the difference. So let's do it. Let's turn it. Oh, there we go. See, we're getting flashy lights. So I'll get my hand out of the way. So I'm going to try to turn it really slowly. And we see the blue LED comes on first, then both LEDs, and then the red one, and then it's off. So it's blue, blue, and then, let's see, blue, right there, and then both, and then red, and then off. So that's the sequence, okay? Blue, both, red, off. And that's when I turned it clockwise. Now I'm going to turn it counterclockwise, and it's going to go red, both, blue, off. So it's going to go this way when we do counterclockwise. So by looking at those two signals, okay, it creates like a truth table. So if this is we'll call it A0 and A1, build a truth table. They both start out off, and then the blue one comes on, so we'll say that's a 1, and then they both come on, and then the red one comes on, and then they go off again. So you get you get this count. Oh, I'm not on camera again, darn it. Sorry about that. So you get this truth table, and we have both LEDs off, then the blue one is on, the red one and the blue one, the red one only, no blue one, and then they're both off again. And if we look at the patterns, you know, 1, 3, 2, 0, then we say we're going clockwise. But if you see 0, 2, 3, 1, then it's going counterclockwise, and that's the way these things work. Now, I've never actually opened one of these up. I think these are very basic. I think they're just a switch inside. It's a mechanical thing. And so let's open it up and look inside. Like I said, I haven't done this before. So how do we get this open? There's these little tabs here. So I'm going to need a small screwdriver to lever these tabs back. I think that will work. And that will work without jabbing myself. Don't want to do that. And I'm sure this thing is irreparable once I get it apart. Okay, so this should now, yep, back is now coming off. And yeah, let me change lenses so you can see what I'm seeing. Okay. You'll be able to see it now. So I've taken it apart. I've bent these little tabs out. I've bent them actually in, and then they come out. So I can separate the two. And then on this side, we see what looks like a bunch of contacts. And not quite sure how that works. That's a strange pattern. And then what do we see over on this side? Over on this side, so here, let me focus on that. Can you see that? It's a rotary wiper, and it has 4 contacts. Let's see here. Let me turn the contrast down a bit here on the camera. There we go. So we have this little contact here. And we have 4 of them. They're 90 degrees apart, so there's 4 of them as it rotates around. And that's what this does. So this is a wiper switch, okay? So wiper switch, I didn't expect 4 of them. I don't know why, but expected maybe 2. And they are all shorted together. So these are all shorted together. So then let's figure out how this part works. So as they go around, some of the wipers will contact this one, which I imagine is the center here. And then there's a series of little spots over here, and I suppose that's this one. And these guys, which is this one. So that's very interesting. So this one gets turned on by, as we go across here, and it looks like it's on, off, on, off, on, off. And we go over here, then this guy will say on, off, on, off, on, off. So does that make any sense? Let's take a look at our truth table. Is that going to be a little too close? Yeah, that's not too bad, but I don't see on, off, on, off. I see on. I see a double on and a double off. And here I see a double off and a double on. So maybe that's how it works. So, yeah. So the phasing of this thing must be that it is on for 2 lengths as it clicks around. So it's click, click. The click, clicks are a little bit of on, and then an off, off. Well, that's interesting. I'd really have to think about that. That's very, very simple and very, very clever. And then you go from here to here, that's 90 degrees, and then here to here is 90 degrees. Yeah, this is a really clever little thing. I would have not come up with this. Hats off to whoever did this. It has some grease inside too, some conductive grease, so that is quite clever. Very, very clever. So really, it's a, well, I guess that makes sense. So, yeah. Let me see if I can fit it in the page here, if I can write small enough. Where am I writing? Let's see here. Let me get it in focus. Okay, so if we have a 1 signal, this is not going to work. Let me change lenses again. All right, let's look at our truth table again. I was looking at this the wrong way. We have low, and then it stays high, and then it goes low again. So it's not really high, high, it's just high. So it's going low for some period of time, then high for some period of time, and low for some period of time. So if we make if we put that, say, on an oscilloscope, it would go high, and it would stay high 2 counts, then it would go low, and it would stay low 2 counts. Then it would go high and high 2 counts, and then low and low 2 counts. And the other one is 90 degrees out of phase. So it will be high, but it'll change here. It will also be on 2 counts, and then on 2 counts, and then off 2 counts, and on 2 counts. So, yeah. So, does that make sense? If we break these up, we would have 1, 1, 1, 0, 0, 0, 0, 1, right? So, yeah, that would make a whole lot of sense. So, all we need to do is create a device that outputs a square wave and another one that outputs a square wave, but they're 90 degrees phase difference, okay? And so that's what this little thing does here. One of them just does a high, low, high, low, high, low, and the other one does a high, low, high, low, high, low, but they are just a little bit out of phase, right? So yeah, very, very clever little device. I like it. And they work great. And they also have a second function, which is that if you push the shaft, the shaft moves in and out. If you push the shaft, there's a secondary switch, and that pushes here in the middle. Let's see if I can do it with my screwdriver. See if I can feel the click. Yeah. I can hear that. It goes click, click, click. And that's a switch that's underneath, and that comes out on these 2 connectors. So these 2 connectors are just a switch, and these over here are that clever little thing with the phase change in it. So yeah, that's pretty cool. So I wanted to talk about another way to do this, and this is the way that I was first introduced to it. I had a brief encounter with this group when I was at Hewlett-Packard. They built shaft encoders. They called them shaft encoders, and they were for motion control, for motors, measuring the speed of motors and positions of motors and things like that. Mostly speed back then, and so those were quite a popular product. And then they came out with these products, and these products were the front panel switch spinny things. And so this is a part number HRPG-AS64, and as it goes around, we could count the number of pulses here. Let's see here. It's 1, 2, 3, 4, 5. 5 times 4. Yeah, so I think this is a 20 count encoder. So as you go around, it changes. It click 20 counts, but then it gets this one is 20 and this one is 20, and then they're out of phase. So it doubles that. So this is like a 40 count wheel. And this one is a 64 count wheel. That's what the 64 there means. And yeah, so I have a good friend who worked a lot on these things. He's probably watching this video. So let's take apart this thing and see how it works. Let's see what we can see inside of it. I kind of hate taking this apart because these are super expensive, but I do have several of these, so I can sacrifice one for you guys, and maybe I can put this one back together because, like I said, these are nice to have. All right, here's this device, and it's a smooth one too. Also, you can buy these either with the click click clicks or the smooth. And this is a smooth rotation. And the back, you can actually even see the little. If I can focus on that. See the little HP logo back there. So Hewlett-Packard back in the day. Let's see here. Oh, there it goes. It's starting to come off. I bent the little pins off in the back, so that comes out. So that's just a metal. These are made out of metal, not plastic. Well, maybe that's plastic. And that one's plastic. This is metal. This is a plastic piece, but this is metal. And there's a little circuit board here that I have to be careful about. And so let's take a look at this little circuit board here, gold plated, of course. Yeah, it's very special. we will need, oops, I'm sorry, change the camera exposure, not the focus. So there's a little IC over here, and we'll have to get out my fancy microscope to take a look at it because it's quite small. And it looks like this is set up for some other thing that's not in this particular model. And then under here, go focus on that, is a shiny stainless steel disc that has slots in it, okay? And so it's like a mirror. So if you bounce light off of that, it will go pulse, 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 because the light will go through and it'll be dark. And if it shines back where the metal is, then it'll be like a mirror. And so, yeah, let me change over to the microscope and we can see what's going on here. All right, I think you can see that little wheel there. And so it is just a little stainless steel wheel. Sorry about that. I have to do quite a slow exposure here for my microscope. So, yeah, so it's just a little stainless steel wheel with slots in it. All right, well, self-explanatory. All right, so this is that little printed circuit board. It's got all the connections over on this side. And the way that this one's connected is there's actually a ground and VCC, because it's an IC, so you have ground and plus 5 volts. And then there's a signal out on A and a signal out on B, so it's like a TTL output. And so that wheel, the center shaft goes through that hole, and so where the little open segments and closed segments are is over here next to that IC. And we can see that IC has some segmentation in it. And so there's multiple photodiodes and an LED, which I believe, if I had to guess, I should have had my friend come over to do this with me. The LED is, if I can point to it without destroying it, the LED is right, see the corner of my screwdriver right there? That's the LED right there. And yeah, it's these guys right here. And that shines light, and then it comes up and reflects over to these photodiodes. And so you can imagine that if you have a coarse on-off, with the slots in that piece of stainless steel, you also have a veneer effect with those multiple photodiodes, and that veneer effect then gives you a lot more phase information. It gives you much more fine, so that's how they get 64 counts, and they get much, much finer detail by using that IC. Let me see if I can rotate it around so it's kind of like this. Yeah, I think you can see a little detail on the IC. Let me see if I can zoom in even further. All right, there we go. Take a look at this. Wow. Now this is fancy. You see, this is a big fancy circuit here with those 1, 2, 3, 4, 5, 6, 7, 8 photodiodes. And then all of this circuitry over here. See if I can focus on that a little bit. There's a lot of stuff in there. That's very cool. And then if we come down here to that little LED, it's actually a fancy LED because it's in the shape of a stripe. So, yeah, very cool. I don't know why there are 2 dyes there. I don't know what that does, but yeah, very cool. Well, these are a lot fancier inside than I thought they'd be. So yeah, there you go. So I'm guessing this one would last about forever, since there's no, there is a moving part, but there's no contact being made, so this would be much more reliable. It might operate at a much, much higher speed as well. Those mechanical switches probably limit quite quickly in the speed that they can rotate. You wouldn't use those for measuring the motion of a motor. They're great for front panels, and that's kind of what they were invented for. But this would be really, really good for a motor that had to spin fast. Or if you wanted a front panel that was like, you know, super speed, you could spin the knob and it would really go. All right, let's look at a quick look at the data sheet here. There's that waveform that I drew. So that's how this one works. But let's kind of look at the specs of this thing. Let's see. Revolution life, 10 to the 6th revolutions. Oh, that's pretty cool. It gives the mechanical strength shaft loads, axial lead and radial lead, Newton meters. Oh, here we go, rotational speed. A smooth one can go to 300 RPM. So yeah, you can spin that thing at 300 RPM and it'll keep up with you. It takes 40 milliamps to run it because it's probably the LED. Yeah, there you go. So yeah, it goes pretty quick.